for all airlines it is applied. Ah. Understood. And that is in their agreement itself. Correct, correct, correct. So they just keep it flying in the air. No, if it stops, you throw it out. Ma'am, you count the number of seats, you count the charges. There's a huge profit in each flight. You just count it out once. 40 rows, 6 passengers per row. 5,000 by that. Just count for 2 hours how much of amount you are getting. In fact, in electrical we take it otherwise. The more it runs, the better it is for us. Yes, because if it stops, it will rust. It will do all the other things will happen. If it is running, you are checking it. The maintenance is being done continuously. So you know that it is running. The checking is being done. As soon as it enters, it will do all the checking. In fact, in one of the automotives now, they have, I think so, added that card. So if it breaks down, you put that card. There's a slot. You put that slot into that, and you will get to know what the problem is there in your car. So those kinds of things have come in. Aircrafts are far above that. So, but as such, I believe if it keeps running, it's. Because if it stops again, it is not about overheating, na? Because you have already stopped it for 20 minutes. You have given it rest. More than. Yes. They don't actually turn it off. Okay. Anyways, then if I have got better operational efficiency, obviously this will lead to improved customer satisfaction, and this is what we wanted. So what is the current scenario? I'm going a little bit places where it is required. I'll just go. So in the current situation, what is there is the movement of vehicles is not monitored. They probably have those registers in place. This guy is going there, that guy is going there. And then because of that, you have got wrong route selection. But nowadays I heard many of them have put GPS on their devices, on their vehicles, so you can maintain. And then there is chances of manipulation also. I don't want to discuss this. We know already this thing. And driver may be overworked. No comments right now, but yes, these are some of the topics which are there. And timely delivery and pickup may not be achieved. This is in the current scenario that we are talking about. And then the usage of the vehicle, you have got overloading, more fuel consumption would be there. This is also there, it may happen, see, if the driver is manipulative, he may add some more material, your vehicle gets overloaded. This is bad for roads also, and bad for the guy also, because the vehicle is consuming more, and there is no maintenance which is there. And ultimately what we have here is there are some other issues which are also there, like there is no data collection, or even if it is there, then it is prone to human errors. This is like prone to human errors means whatever the driver says, I agree to that, fine. And then if the data itself is not okay, analytics cannot be done. Analytics, do you know that nowadays, if you go online, there are jobs for business analytics also, and they are paid very well. Also means through remote also you can do it now. So analysis is one important issue. Then you have got, see, if you don't know what is happening, obviously there won't be any response. And the last thing is again inefficient asset management. So if a truck, I don't know how much it costs, but maybe it should be a big amount. If it is not working properly, that is where I'll lose it out. So what is my line of action is, one is the hardware installation first, software development. This is for IoT I'm talking about. I'll be installing sensors and all of it. Software development is to be done for that. Then I go for data collection. Why software installation would be required? Anybody? What kind of software? Is it IoT software or is it something else? For hardware platform, basically if I'm collecting the information and all of it and doing it, for that it is required. Then I want the data analysis to be done, then the corrective action if required, and the user awareness also. User awareness means the driver should also know what is happening. So this is my line of action, where I'll first go with my hardware installation, then I go with my development of the software, collect the data, analyze it, do the corrective action, and then move ahead with it. Software development can be first also, but the only thing is, after you get the data, you exactly know what the problems would be and at what speed the data is coming and all of it. Then the next thing is, what is the hardware installation made out of? So you have got GPS trackers, I'll come to this later on. Then you have got onboard diagnostics. This is a big field actually. If you just go online and check it out, onboard diagnostics for automotives is a big field again, you know, and there are standards and all of it available all through and through. So this is onboard diagnostics, means on the truck itself or the vehicle itself, the diagnostics should be done, right? Then some fuel level sensors and some temperature sensors. This is not the full part of IoT. This is only the sensors that we are talking about. So let us just explore. Let us say if I want to do it similarly for a house, what kind of sensors do I need? Let us say for this room, I want to go for IoT. What kind of sensors? These are for GPS tracker, won't be required, but any other sensors that we may require here in the room? One is temperature, obviously. Oxygen level, very good. Oxygen level, very good. Maybe flow of pollution, illumination, very good. Flow of air or something like that. So we can have all those things. Plus, for the furniture, nobody thought about it. Is it being maintained properly or not? What has happened? Some kind of a sensor can be there. Nowadays, there are some pressure sensors which have come in. So we can utilize those also in place if required. So now what happens is, when I am going for IoT platform development, we have got, let us say, different kind of vehicles which are in place, and they will be sending the information all through and through to the cloud. So now it is required for me to put what is a cloud, because if I don't tell, then you will be in still. So basically you are using Google Drive. That is also cloud kind of a thing. But this is like, you know, when we say IoT platform development for a company, you have to pay for it. Right now for Google, you are not paying for it. After 15 GB, you will be paying money for it if you want to use it. So the company will obviously be using more than that. So it will not only pay for the space, but it will also pay for collection of data, analysis of data and all of it, and transfer of data to its own system as well, maybe through web or whatever it is. So this is cloud. Then there is something called as edge computing. Again, I'll come to that. When I come to that, those slides I'll just scroll through faster. Edge means the system itself processes it before going to the cloud. So cloud is a bigger aspect. Edge is at device level, and fog is somewhere in between. So there might be like a collection in between, and then multiple elements will get connected to that, like a substation for electrical, or like if you go for, you know, load dispatch centers in electrical, you have got what we say, state LDCs, RLDCs, then NLDC. So you can consider state LDC as edge computing, RLDCs as fog computing, and NLDC as the cloud computing kind of a thing. So that is how it works, how the data is to move, right? And even the processing. So if there is a problem in state, SLDC can manage it at that own level. It need not go to the NLDC. Maybe NLDC can be reported that this problem had occurred, but we have solved it at our own level and it has been taken care. If it is going out of hand, it will go to RLDC. But this is for hierarchy, where there is no hierarchy here. This is only, we are talking about the level at which it will work. Cloud is a centralized thing. Fog is a little bit more distributed. Edge is further distributed. So now what happens is, my vehicles are flying from here to there, maybe from Nagpur to Mumbai and Delhi to Bhopal and Hyderabad to Tamil Nadu, Chennai and all of it. And what am I doing is from each and every vehicle, I am collecting information into the cloud. Once that information is collected, I will sit and analyze it. I'll get the graphs, routes and everything that is required, right? And I can exactly get the analysis of what is happening where through the platform. So even I had just put it like, if the driver is not properly utilizing it, I can find that also, and there would be a tracking happening in his or her mobile also as well, so that I can get all the information there. So that is why in the previous slides we saw that the user awareness is also necessary. Now what would be the challenges that come into implementing for fleet management systems? One is obviously data security and privacy. So this will always be there. In any of the case study that you put, this will obviously be there. Next thing is scalability. Here scalability is a important aspect, because I put it in one vehicle, now then second one, third one, fourth one. I have 5 vehicles already with me. I buy the 6th one hopefully someday. Right now I don't have that much money, but let us say I have the 6th one also coming into the business. So it should be able to scale up easily. So that is another issue there. Then you have got data integration. It should basically be in a proper flow of it. And then you have got obviously this will be there. You have initial cost would be included into that. And then you have got connectivity issues as well. See, if it is traveling in places where the connection is not there, I don't know what is happening at that time. I really have no idea. So that is another issue that may happen. Then device compatibility and interoperability, I have already covered it. You have got regulatory compliance also. This I won't go into details of it, but there are some rules and regulations by the governments also. So you need to follow them. That is compulsorily required. So we need to see that as well. This obviously would be there. When COVID came, people started resisting online classes and all of it, but then slowly they found that they didn't have a choice, so they fell in line. Similarly, the driver and all of it will have to be taken into confidence that this is good for us and helpful for us. And obviously there would be data overload, but as I said, if we have got proper analytical systems, it will take care of that thing. And then the maintenance of IoT would be an added burden on the system, obviously, because earlier it was not there, now it is there. So GPS trackers will be installed in each vehicle, and as it moves, it will be transferring the data onto the cloud. I may not be able to give much time to this, but let us say if it is possible. So in GPS tracker, the number one thing that it is it provides me location data of each vehicle, enables geofencing. Anybody who knows what is geofencing? It's like a virtual boundary that you create. So you can just it is basically a geographic boundary that you create. So basically what happens is, in geofencing, fencing means you stop somebody from coming in, or you stop somebody from going out. So you create a virtual geographic boundary by that, and if that boundary is breached, then you get a signal into that particular thing. That is geofencing. And then you have got assist in route optimization, and yes, historical trip playback. So this is obviously also there in Ola, if you see, for the consumer also. And then integrate with mapping services like Google Maps and all of it. And then you have got support theft recovery in case of vehicle theft. So this is all known. I'm just scrolling a little bit faster because majority of the things are known to us. We already. Now, what are the requirements is, one is high sensitivity for the GPS receiver, one is cellular connectivity. If the connectivity is not there, it will basically not work. You need to have battery backup, right? Because it is installed in the vehicle. If the battery supply is gone, it will not work. And then you need a tamper resisting casing also, because anything can happen. So this is one of the devices which you can just go through, that is GeoTab Geo9. This is a product actually. So you can just go through. I actually had put a link here, but I don't think we have time for that. And these are the benefits that it brings you. I'll share it with you. At the bottom you have got the website for it. So this GeoTab, basically Geo9 is a product. It's a device that you can actually install on the vehicle directly. And the benefits are like it has plug and play LTE connectivity. It has got built-in accelerometer, and it has over-the-air updates. Over-the-air updates means automatically the updates are installed on it. And then you have got expandable with 10. I'm not able to see. Yeah, whatever it may be, but it is expandable with the technology. This is the place, the YouTube channel where you can go and see how Geo9 can be installed. There are some other trackers also for GPS. One is Calamp, one is Trackemo, one is Verizon. So this is where I wanted actually to explore more time into. Unfortunately, we have run out of time, but these are some of the companies which you can also explore a little bit. Then there is something like onboard monitoring system diagnostics which are there. So it basically monitors vehicles in real time. As sir had said yesterday, the helicopter itself should tell that I am not ready to fly. So here we'll be able to see whether the vehicles are ready to fly or not, or run or not, or whatever it is. It will detect malfunctions and emission related problems. It will store the diagnostic information for later retrieval, and standardizes the vehicle diagnostic systems across the manufacturers. This standardization is really important. Later sometime, if it is possible, I can discuss with you, but standardization, without standardization, nothing works properly. So these are all the facilities which it should provide. Right? Vehicle speed and idle control and all of it, exhaust systems, ignition systems, fuel delivery, emission control, transmission, energy management, and all of it. This is the history of OBD. This is onboard diagnostics for vehicles basically. See, vehicles is a big, for all those people coming from different backgrounds, let me tell you, these companies are also recruiting in big numbers nowadays. Whether it is Mahindra, Tata, whoever, they are recruiting in big numbers now, because India is progressing like never before. As such, vehicles will increase. This is one of the factors through which we can measure. People will own their own vehicles, so they have got a good option. And this onboard vehicle management is not only for fleets but individual vehicles also. It is a good option that we have. So these are some of the benefits that we see there. That is, one is early problem detection, the other one is reduced emission, and you have got easier vehicle maintenance and repair, standardized diagnostic procedures. Usually what happens is, again I'll get back to the same thing. If it is standard, it is better. You know what is to be checked first, then what is to be checked, so on and so forth. And then you have got enhanced vehicle reliability as well. So the key components that we have, one is the engine control unit. If your student gets placed, and suddenly he comes after 6 months, I have faced this thing. They suddenly talk with these terminologies, ECU. You don't understand what is an ECU, so then I have to search it out, what is an ECU and all of it. That is, engine control units are placed, and these are used for onboard diagnostics again. Then various sensors throughout the vehicle are there. Nowadays, I think so, there are 360-degree view, fuel sensors. In fact, they'll tell you how many kilometers are left before you go for a refuel. A lot of things have come in. And then you have got diagnostic connector port. This is what I was saying. This is actually now happening, and if it gets standardized, every vehicle will have to have that onboard diagnostic. In fact, some of the vehicles I saw on YouTube, which in India also has got it. So you have to just put it, connect to it, and you get what is the situation. and warning indicators like engine light and all whatever it is. So that is the things. In fact, majority of them nowadays, give you early warning anyhow. So these are some of the protocols, OBD protocols. One is ISO 9141-2, SAE, JE, GIAN, whatever it is. So these are some of the protocols. One is 9141-2, and then there is, I can go into detail of it, but again, then there is that SAE J1850 at the bottom, and the last one that you see is called as CAN. So this CAN is yes, where basically majority of the work is being concentrated into. So this is also which is there, and then this is a repetition. So for telematics OBD, there is this company called as Samsara again. So you can just scroll through it, and I'll share with you. You can click on the link and it will go and open that website. So this device is quite similar to GeoTab, but other than GPS tracking, it also provides onboard diagnostics to you. So these are some of the online market surveys taken from these websites, where it shows you how handheld tools have changed, and mobile based tools have improved, and PC based tools and others have improved over a period of time for OBD. We are just talking about onboard diagnostics only right now. And then you have got the by vehicle type, how it works basically. So year wise you can see how the difference has come up for electric vehicles, how the market has changed, and other things also which are visible there. This is another aspect to that as to how things are changing. So if you see, for passenger vehicle and commercial vehicle, it is actually around 40% increase that we can observe there. From these are two more websites which I have. Both are from Wikipedia, and it actually gives you a lot of information based on onboard diagnostics. That is where actually I started my lecture with that. I'll give you information, you explore it as much as possible. These are some of the websites where you can go and explore. It's a huge one actually, so I could not concise it into a slide as well. So one of it is onboard, the other one is OBD2 PIDs. OBD2 is the current one that is going on. Then you have got some fuel sensors which are required. It provides you accurate fuel data level. You will be basically managing the vehicle to the level that you will also be sitting in your place and see that what is the fuel level in a particular vehicle exactly. So this would be as many vehicles as you have, you will get it on a continuous basis. Then if there is a potential theft, you can easily detect it again through that. Assist in fuel consumption analysis, also optimization. For fuel sensors, what is required is high accuracy, compatibleness, resistant to fuel sloshing, and all of it. Sloshing usually means when it moves, there would be those kinds of things will happen. The fuel will move up and down, so that should be taken care of, and it should integrate with the other things. Now in this fuel sensors, usually what I have observed is in majority of the cases they will specify that you can have a plus or minus 1% error margin, not more than that. Then we'll just skip this one. So usually it also follows certain requirements, like IP67 enclosures are also required for these kinds of things. And if you see here, there is one company, Rochester, which is there. It provides you with fuel sensors also. Now the point what I'm trying to make it is, you have got different these equipments. So if you actually want to implement it, you need to get these things, put it on place, and you will be in a position to utilize it. This is for temperature sensors and what kind of connectivity and all of it requires. So it should be able to work on different temperatures, obviously, you know, you go to Kashmir, the temperature levels would be different. You go to Chennai, temperature levels would be different. You go to middle of India, the temperature level would be different. It should be able to do comply with all of it. And otherwise also, you know, nowadays you have a temperature sensor anyhow in the car, so you can just extrapolate through that. High temperatures are usually to be avoided as much as possible. However, the range if you give is -40 to 60 degrees. Accuracy plus minus 0.5%. Battery life should be 2 years is what we can see, and it should work on these technologies. Monet is one of the companies which again provides you with the temperature sensors there, and it claims to have a battery life of around 12 years. So you put it into that and it will keep on working. And also it claims to work in a range of -40 to 125 degrees centigrade. That is a huge variation in which it works. Then when we go to IoT gateway, it is used for inter-device communication and device to cloud communication, and then you have got data processing, and this we already saw, like, you know, that platforms which were there are also part of this thing as such. So you have in a gateway, you have got a sensor layer. This is the first one. Then you have got a network or data acquisition layer. Then data processing. This is also what I told you. Like, you know, you have to first sense it, acquire it, process it, and apply it. So these are the basic expectations that we have. One is collect and aggregate data, provide edge computing. Now I assume you know edge computing means some analysis would be done at the vehicle level itself. It will not go to the cloud. The problem does not go to the cloud. Transmit data to cloud. This is as and when required. The second one is for local data processing. If there is something that is required, it will automatically do it. Enable over the air updates. Over the air means automatically it should get updated. And requirements, multiple connectivity options should be there. Powerful processor should be there. Rugged design, because in vehicles it will be moving here and there. And expandable storage should be there. This is again one of the gateways which is available. This is from Dell, which is there. And this can be utilized. The best part is that this particular thing works from -30 degree to 70 degree centigrade. So that is a huge thing. It has got a memory of around 2 GB, that is RAM, and a storage of around 32 GB with it. So that is a huge thing that is available with you there. It's quite powerful as well. Some of the other equipments that we may need is tablets, smartphones, cloud platform, network infrastructure, and application software. Usually this application software has to be developed at your own end. It will not be provided by anybody. So as per the requirements, you have to do that. And then we go to cloud computing. So I assume that I have already covered this thing. We'll just go a little bit faster here. So you can just go through the slide here. This is how it works. A computing model that delivers on-demand computing services over the net from remote data centers, allowing users to access and utilize these resources without direct active management, enabling scalability, flexibility, and cost efficiency. This is for cloud. In fog, what happens is it extends cloud computing by creating an intermediate layer in between the computing nodes and the end devices. So this actually helps. This is a kind of evolution that has happened. This helps bring down the load of the cloud computing thing, and it basically therefore helps in security, latency, and it is more efficient. For edge, it is a distributed computing model that has computation and storage closer to the location where it is needed. That is why it is called as an edge. To improve the response time and save bandwidth, this is like, if you have got huge amount of data coming in, you just assume like Hyderabad is there, it's a big city, how many LDCs would be there and how much of data will be generated. So if more amount of data is generated, you will require the bandwidth on which that data can be transmitted, which is not a possibility to have every time. So basically what we do is we reduce the information we fine tune it and then send it. So that is where edge computing can come in. Now basically you cannot divide that cloud computing is only good or fog computing is good or edge computing is good. It depends on what is your requirement, how you are going to implement it. If it is vehicle management, you need to decide. Obviously the cloud computing would be required, as well as you may require edge computing. Maybe fog computing may not come in that case. So yeah, this is obviously we have covered this thing, and then there's another one where I have given a very brief comparison. So in cloud you have got a remote data center, whereas in fog you have got a local network data, and edge is on the direct. But edge will not be that powerful, it cannot decide everything. You need to think this way also. Edge is like a small officer in place. If there is a big problem, it cannot decide the things, it has to go to the cloud anyhow. Can anybody tell me what is latency? Delay, right, delay. So delay would be highest in cloud, fog would be lower and lowest in the edge. Processing power highest because obviously cloud has got more resources, and lowest in edge. Storage virtually unlimited, significant but limited, and edge will be obviously quite limited there. Response slow, faster and fastest. So I'll conclude with the thing is like, IoT can be utilized optimally to manage these vehicles. Vehicle management is of EVs actually need to be explored a lot here. What I have told you, like fuel level and all of it, if it comes to EV, you have to go to battery then, and probably the part would be different totally here, because EVs may not be used for transportation. Transportation means like for material transfer within the city, it may be used. So that needs to be explored. In fact, it is still being worked on. IoT needs to be propagated as, anyways, this we can just leave it off. So the fundamental was like I tried to, in more than 2 hours, a little bit more than 2 hours, what my intention was to get you into the working of IoT, and to basically understand through some case study that how it can be actually implemented. So now we see that there is geotab is there, monitor is there, these are all sensors, these are all on the ground. Then from there the data would be collected through the IoT gateway, and it would be uploaded onto the net. Once it is uploaded onto the net, then you have got enough amount of information. Then what you can do is you can analyze it, you can process it, and you can go ahead on it. If you go online, there are a lot of data sets available on this also. So for fleet management, not as IoT but as fleet management itself, the data sets are available. So how it can be best managed. You all today probably your lunch is there in visitors block, same place yesterday where we had it, not where you all had it but where others had it. It is still there, but from tomorrow it will be in Kalam Hall. So there is one guy from Sweden who has come in. He is moving. You can find him in the campus also. He works on traffic management again. So you can just interact with him also in this case if you all are interested on talking on it, how they work on traffic management and how IoT can be used for that thing. So there are a lot of applications. I personally did not choose anything from CS and EC and electrical because it would be confined to understanding part. I took a very generalized topic where everybody could connect with it. So this would be all. If there are any questions, I'll take it. Okay. So a little bit from my side. These are 3 books which I have done. The last one is from a conference. The second one is edited one. The first one is self-authored. And this is one of the upcoming conferences on which we are working on. This is to be conducted in NIT Srinagar. The call for papers is open now. This is the second conference that we are conducting there. Thank you. If there are anything else that we need to discuss, we'll have it. Otherwise, we'll proceed for lunch. And the next session would be in electrical department. That's it.